For two objects involved in a collision, their momentum is conserved. Okay, so total momentum before a collision equals the total momentum after a collision. So in mathematical form, this is what it looks like. So you have the mass times velocity, so that's momentum of each object initially and finally. Okay, so the numbers 1 and 2 by the masses and velocities indicate the two different objects. So on the left, we have the mass and velocity of the first object plus the mass and velocity of the second object. And then on the right, we have the same again, mass and velocity of first object plus the mass and velocity of the second object. The letters I and F indicate initial and final, so you'll notice both of them on the left have an initial. And the masses we're not assuming the masses are going to change. We're going to assume they will stay the same and the velocities will change. So we've got initial velocities on the left and final velocities on the right.
A 10-gram cue ball moving at 3 meters per second strikes an 8-gram 8-ball moving in the opposite direction at 2 meters per second. If, after the collision, the cue ball's velocity is reduced to 0.5 meters per second, how fast and in what direction is the 8-ball going to move? So again, we have listed down here at the bottom, we have our equation. So it says a 10-gram cue ball. So we'll go ahead and make this our mass 1, or for object 1, is going to be 10 grams. It is moving, so the same object is moving at 3 meters per second. So the velocity initial is 3 meters per second. Strikes an 8-gram 8-ball, so M2, we're going to go ahead and start working with our new one. 8 grams. So that was gram, and this was gram as well. This was meters per second. Moving in the opposite direction at 2 meters per second. So that's going to be our velocity 2.
The opposite direction from what we assigned our first object, we need to put a negative sign in front of that 2. So it's going to be negative 2 meters per second. The negative sign just indicates direction.
If after the collision, the cue ball's velocity is reduced to 0.5 meters per second, how fast and in what direction will the 8-ball moving? So it's reduced to 0.5, so that's going to be our final velocity for the cue ball. And the cue ball was our mass 1 object. So V1 final. Again, make sure that we're writing which one is which. V1 initial, V1 final is equal to 0.5 meters per second. So it says how fast and in what direction is the 8-ball moving. So we're just going to go ahead and plug these in. But first, we never work in grams. We always want to work in kilograms. So we're going to take that 10 grams and we are going to move that decimal place over 3 places to get kilograms. So it's again going to be 0.010 kilograms multiplied by our V1, which is 3 meters per second, V1 initial, plus our mass 2, which was 8, but again, that's 8 grams, so we want to go ahead and convert that to kilograms. So moving that over 3 spaces, that becomes a 0.008. I can do a better 8 than that. Multiplied by our velocity 2, which was 2, equals
Negative 2.
Oh, negative 2. Yes, you're correct. Negative 2, because we have that negative that was right there. Equals to mass 1, which was 0.010, times your velocity 1 final, which was going to be this one right here, multiplied by 0.5, plus M2, which was 0.008, multiplied by our velocity 2 final, which was what we're trying to find out. So V2 final. Okay, so again, we're going to go ahead and get these numbers simplified. So what's the first thing that we want to do?
Well, 3 times 0.01 is going to be 0.03. So we're going to go ahead and get our momentum for our object 1 before the collision. We want our momentum for object 2 after or before the collision as well. So 0.008 times negative 2 is going to be negative 0.016. And that's going to be equal to the momentum of object 1 after 0.01 times 0.5 is going to be
0.05, or well, not 0.05 because it has the decimal there. It's going to be 0.005.
Plus 0.008 times what you're looking for, which is final velocity of object 2.
Okay, so we can easily just go ahead and combine these together. So 0.03 minus 0.016, what does that give us?
0.014.
So we'll put this up here. 0.014 equals to 0.015 plus 0.008 times the velocity of your second object final. So how can we simplify this side?
Well, that 0.005 needs to come to the left because we need to isolate v to f. 0.014 minus 0.005, or not go, 0.009.
Not 8, it's 5. Try this again, 0.005. So when we subtract this out on that side, that becomes that. So we can subtract 0.005, and that becomes 0.009.
Mm-hmm.
And again, we want to subtract because since it's not multiplied by anything, you're not going to divide. So to get that number on the other side, you just want to do the inverse operation, which is to do the opposite. So if it's a plus, you want to subtract that number to get to the other side. If it's a minus, or if it's negative, you want to add it to get to the other side. So that's 0.009 equals
0.008 times v to f. Now we're going to divide out the 0.008 from both sides so that we can get velocity by itself.
so 0.009 divided by 0.008, and you should get
1.125 meters per second.
so our final. That is going to be our final our answer. Yes, 1.125, and that's going to be meters per second.
Mm-hmm.
Erase this real quick. All right, guys. Well, that does it for us. We'll see y'all next time.
Yay!